Okay, hello everyone. I am Shiv Prakash. This is Scholar Department of Practical Engineering, IIT BHU. Let's start the session. Previous class, I started with the jet transform and ROC. Where exists the ROC. Okay, jet transform we know the xz equal to n is equal to minus infinity to infinity xn jet power n. But it depend on the ROC. The jet transform you can find by taking the ROC. Okay, In the previous class, I take an example, two examples, like xn is equal to alpha power n un, and second one same xn minus or alpha power n u of minus n minus 1. Okay, let's take this in example and find the z transform. For this one, z is equal to n tend to minus infinity to infinity alpha power n un. There is a un, that's why the summation limit will be changed, and it will be n is equal to 0 to into z power of minus n 0 to infinity because of un. This will be alpha n z power minus n. In this form, you can say this will be n is equal to 0 to infinity alpha z inverse to power n, and the z transform of this one will be 1 divided by 1 minus alpha z inverse, or you can say z divided by z minus alpha. In the other case, xz is equal to, here n is equal to minus infinity to infinity. First we write formula minus or alpha power n u minus half m minus 1. Here the u minus half m minus 1, it means minus infinity to 1. The limit will be changed. N is equal to minus infinity to 1. Minus will be common here. Alpha power n into z inverse. This is z power minus n. Okay. This will be minus of summation n is equal to minus infinity to 1. You can change this one 0 to infinity. Then there will be one term is missing here. Then that term we can add here. So alpha power n in the end there is a term which will be negative. This one, this will be alpha power n, or you can say this will be a minus uh, one term which will be common here in one. This will be minus of n minus 1 into z and n plus 1, like that. 0 to infinity, you can take a common alpha inverse z. This will be a n plus 1. If you reverse the order, then this will be a positive term. Okay, this will be n, but this will be a positive. That's why I could take n minus n common. Then this will be alpha inverse. We will multiply of this one. This will be n plus 1. To find this one as 0 to infinity, then it will be common. The minus of alpha inverse z, one term is common. Then n is equal to 0 to infinity alpha inverse z to power n. Then this will be a same formula, minus of alpha inverse z divided by 1 minus alpha inverse z. With common alpha inverse z will be cancelled out. Then this will be make same as z power z minus alpha. In this case, both are the same z transform, but you can find the difference in the ROC, region of convergence. For the u1, u1 will be greater than 0. This will be a less than 0 available. That's why in this case the mod of z would be a greater than mod of alpha, but in this case the mod of z should be a less than a mod of alpha. In this case both ROC will be changed, but the z transform will be same in two cases. That's why ROC is important thing in the transformation of the signal. Alpha greater than alpha, it means if you take a radius, take a circle of the radius alpha, then ROC will exist outside the circle. In the other case, if you take a circle with a radius of alpha, same in this case the ROC is less than alpha, it means inside the circle. Region of convergence, this is the region of convergence for this one. Okay. If the Z transform in the form of rational like a Pz divided by f Qz, then numerator you can written as in terms of the poles and 0, then this it will be Z1 Pz should be written as like that, can be Z1 Z2 dot dot Z minus Zl. Pole, same thing, pole can be written as Z minus P1 Z minus of P2 dot 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 Z minus of Pn, where you can see Z1 Z2 and Zl is the zeros of this task, this function, and P1 P2 Pn is the poles of this function. It would be like between the a unit circle, to take this one radius of 1, it may be like the inside the unit circle, poles written as in cross and zeros written as 0, somewhere anywhere it can be, depending on the number of poles and 0. This is the unit circle defined as the Z omega circle in the Laplace. Okay, and also define the ROC of the system. For the find the ROC, take some example how to find the ROC and what is the ROC of that function. First one, if you take alpha power 2n u of minus n plus 4. Okay. Now what is the ROC of this function? In this case, same thing you can write as this one. We have to say this one. This will be a negative. It means this will be a less than something. Then what is the function? This function is alpha power 2n. There is alpha square. Which one is here? Before the n, you can take this one. Alpha square into z inverse. It should be lesser than the 1 because of this will be a negative. If this is the first, it means the outside the greater than 0 function, greater than 0, then modulus of z should be greater than 1 or something case. But if there is a negative, then it should be always, because of this is the left sided signal. Left sided signal, the our function will be lesser than the 1. Okay, we find this one, the alpha square mod of z, it should be less than 1, then mod of z less than alpha square. The next example, if you want to take for 1 by 3 to power minus of 3n uf n minus 4. In this case, the alpha is this one, whole thing. This is the positive. Then we have to take z should be greater than this one, 1 by 3 to power of minus 3. Okay, this will be, I think, z should be greater than 3 to power 3, because alpha is here is 1 by 3 to power of minus 3. These are two functions. It will be greater than alpha, mod z greater than alpha, or modulus of z will be less than alpha. But what happens if the two function is there? Then what is the ROC? Like this function, power n un plus 1 by 3 to power n un plus 1 by 4 to power n un. In this case, this is the un positive, right side signal, then mod of z will be greater than 1 by 2. In this case, mod of z will be greater than 1 by 3, mod of z will be greater than 1 by 4. There will be three circles. This is 1 by 4, 1 by 3 and 1 by 2. Suppose this one is 1 by 4, another circle 1 by 3, another one is 1 by 2. Then what is the ROC, actual ROC of this system? For this system, ROC should be greater than 1 by 4, it means here, but here is defined as the ROC greater than 1 by 3, greater than 1 5 you can see here, but this one is the of Z should be ROC greater than of 1 by 2. This is the 1 by 2. Then it means the overall ROC of the system is of greater than of, which one is a larger than this one? 1 by 2. Means outside this bigger circle. If something somewhere is ROC is less than in the less than case, then which one is the minimum quantity, then ROC is exist there. Like the next question, I will take an example. I take this one. This one, mod of alpha should be lesser than the mod of z should be less than the alpha square, because of this is the negative thing. The next example, if there is a negative of power n un, you have minus f minus of f minus of n. If there is a negative or positive here, the left side and right side of signal, then the ROC is defined by them. Plus minus of 1 by 3 to power of n uf minus n minus 1 plus minus of 1 by 4 to power n uf minus n minus 1. Okay. In this case, mod alpha should be less than because of the negative thing, left side signal, then less than of 1 by 2. Because of mod of alpha it means mod of minus of 1 by 2. It means 1 by 2 only. In this case, mod of z should be less than or 1 by 3. In this case, mod of z it should be less than or 1 by 4. In this case, take the 3 circle. This is 1 by 4, 1 by 3, 1 by 2, by 4, 1 by 3, 1 by 2. But there is the less this other ROC means less update ROC. Then which one is the lowest ROC? That one is the main ROC of this function. It means the mod object less than of 1 by 4, which is the lowest. This one. That is the ROC of this function. But what happened in the two-sided ROC? How can you find two-sided ROC? Like 1 by 4 to power of mod of n. 1 by 4 of mod of n means you can open this one modulus. Mod of n it means n should maybe a positive, maybe negative. And if the positive, then which one function is will like? And when the n is negative, then which function will be like? Okay. Then it should be positive. The first one take positive for n un. Then next one negative minus n u of minus n. This is not only u of minus n. This will be u minus n minus of 1. Why? There is a reason. Who can't we take only minus of n? This is the discrete signal. Suppose there is a continuous signal. Then un would be written as like that. And u of minus n is written like that. If you add the both signal un plus u of minus n, then in the discontinuity, the 0, the signal is taken half of this one, half of this one, the signal will be 1 only here. Then total will be like 1. 1 is here, 1 is here, then total signal is 1. Entire signal value is 1 here. Because there is a discontinuity, you can't be fix the numbers value at 0. In this case, I have taken as half of this one and half of this one taken, and whole the signal will be 1. At a discontinuous t point, there will be 0 at 0 point. Then in the continuous signal, oh sorry, ut not n, oh, u of t, sorry for this. This is the continuous signal ut minus of u of minus t, this one ut plus u of minus t, it will be 1. But in discontinuous theory, u of n is written as at 0, 1, 2, 3, 4, 5 dot 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 to infinity, like that. Value is 1 because there is a unity function. And u of minus n, if you take u of the value is 1 only here, because this is the discontinuous signal. This continuous signal value is fixed 1 at every point. Value is 1, 1, 1 here also. If you take in as like a u of minus n, then u of minus n written as like that. Minus of infinity. If you add this one, u of n plus u of minus n, in this case this will be a 1 1, but here in the at 0 the value we have added directly, then it will be 2. Then it can't be says that un plus u of minus n is equal to 1. No, discrete signal, because of the every point has value is 1 1, every point value 1 1, then here is also 1, the 1 1 will be taken as the 2. In the, that's why in this continuous case it will be added as un plus u of minus 1 minus n minus of 1. It means you remove the one term, which one is at 0. Yeah, this one. This is not 0, this will be minus 1. This will be minus infinity to minus of 1. And this will be a 0 to infinity. And at this that time, this whole signal will be 1. This will be minus infinity to infinity signal. This will be minus infinity. This one is infinity. Okay. That's why I chosen as u of minus 1 here. Then what is the ROC? This function is un, it means it will be greater than of 1 by 4, but here mod object would be less than, because of this is the left sided signal, less than of 1 by 4, because there is a minus of n, that's why this will be inverse. Taken only this one, alpha is 1 by 4 to power minus of n minus 1 also, that's why we have taken as 1 minus of 4. It means the mod object should be lesser than 4, greater than 1 by 4 and less than 4. Then in this case the circle will be looks like that. There is two circle, first one at 1 by 4, second one at 1 4. So this will be 1 by 4, this will be 4. And in this case ROC will lies between them. Yes. Mod object, it will be greater than of 1 by 4 and less than of 4. Circular ring, you can say. This is, oh sorry, this is the ROC. Okay. What is the ROC of delta m? A unit impulse discrete signal. What is the ROC of this one? ROC is defined where the value of the signal is summation is absolutely summable. The function will be absolutely summable. It will not infinite or minus infinite. Then ROC will be defined where the signal is stable. So signal is summable. In the previous case, suppose there is no boundary, then here signal will be infinite. In this case, suppose here this signal will be present at 0 to infinity. This signal is present minus infinity to minus of 1. Okay, if you put infinity here, then this value will be 0. If you put the 0, this value will be 1. But the function of this one will be z minus 1 by 4. If this value is less than 4 minus of 4, then it will be goes to 0. At 0, this function will be infinite. ROC. That's why the function will be greater than of minus of 1 by 4. Mod z should be greater than of minus of so greater than or 1 by 4. Same thing in this case, z divided by r, z minus 4. If you taken as n is equal to minus of infinity, then this will be 4 to power of infinity like that. But here the function will be z minus 4. If you take the infinity z, then this will also infinity. Minus infinity we taken this one. Thus there is a problem. So that's why the signal should be in between them. Then ROC of the delta function. And first of all find the try to find the z transform of this one. Then you can find actually ROC where it exists where the function will be 0 or infinity. For the finding the z transform, the value of function will be minus infinity to infinity del f and z to power of minus of n. This z del n will be present only on 0. Okay, it means n is equal to 0 here. Then z to power 0, it will be 1. There is no function where to go this value goes to the infinity or unbounded. That's why the entire plane, that G plane is the ROC for this signal. Okay. Suppose there is a function like that, del is equal to n minus of n. Then what is the ROC of this function? It will be same as entire function or different thing. For the del n, the ROC is entire the G plane. But what happened in case of z of n minus of 1? Then we have to find same G transform. It will be summation of n is equal to minus infinity to infinity del of n minus 1 function xn into z to power of minus of n. In this case, we have to put the n is equal to 1 because of z is n minus 1 is here. Then if you put a z is equal to n is equal to 1, and this will be a z of minus of 1. This will be 1 by z. It means the ROC should be greater than 0. What object should be greater than 0 in this case. ROC given. This is not entire the plane. will be greater than 0 because of this one only. There is a 1 is there. Then what happen if a signal xn is equal to 1, 4, 3, 2, 5? What is the x taken as? This will be 0. What is the ROC of this function? How can you find the ROC of this function? Okay. And what is signal? Signal can you write as 0. Here arrow is there. 0 value is 3. Then at 1 value is 2. As 2 value is 5. 0, 1, 2. Here minus 1 value is 4. At minus 1 this will be 1. At minus 2 value is 1. This is the signal, and you have to find the ROC for this signal. First of all, find the G transform of this one. Before finding the G transform, first of all find the expression of the signal. Without taking the expression of the signal, how can you find the G transform? First this one, in this one you can write as 1. This is the G3 at 0. This you can written as 3 of del n. This is del n. Del n is equal to this one only. Value of 1 at 0. This function is write as del n. If you multiply by 3, then this will be 3. 3 del n plus this one at 1. Then value is 2. 2 del n minus of 1 here at 1. This is a delay signal. Next one is 5. 5 del of n minus of 2. But there is a negative also. Minus of 1. Minus 1 it means the advanced signal. Advanced signal delta will be positive. Then 4 del n plus of 1. This will be plus of 2. This will be 1. It means del n plus 2. This is the function written by this one. Del, this will be del 0. This will be del n plus 1. This will be del n plus 2. This will be del n minus 1. This will be n minus 2. If you convert it into Z transform, then we written write as Z is for Z to the power minus of n, minus of n, n plus of n. You have to put the minus 2. This one minus 2 means Z to the power of minus 2. Z power minus of minus 2. It means Z of square. In this case 4 Z of power of 1. This will be 3 only. Z power 0 1 plus 2 Z power of minus of 1 plus 5 Z power minus of 2. Okay. ROC of this one, then mod of Z should be, if mod of Z infinity, you can't be take less than infinity. For these two signal, the mod of Z should be less than of infinity. Here you should taken as mod of Z should be greater than 0. If you, this is 1 by Z. 1 by Z means we take a Z is equal to 0, then what happens? This function will be infinity. That's why the mod of Z ROC should be greater than 0. then entire signal, the ROC it will be greater than 0 and less than of infinity. This is the ROC of the this function. This type of function you can find the ROC by taking like that. Yes, anyone have doubts?
Yes, sir. The one jet mode object less than infinity and difference of mode object greater than 0. Again in this regard.
Okay. Z transform is the summation. Then those functions should be summable, absolutely summable. It means the function should not be infinity at any point. You have to find the ROC for that signal. In this case, suppose if you put the infinity here, so I am writing once again also z square plus 4 of z plus 3 2 by z plus 5 by z square. Okay. If you put in the infinity here, then what happen? This will be whole function will be infinity. This one also, if you put the infinity here, the whole function will be infinity. There is no z, then you can say this will be entire z plane is the ROC because of there is no z function. Okay. You know about the z should be r e power j omega d, and this is the ROC. If you put the infinity, then the r will be infinity. It means you have to you have putting the r is equal to infinity. Then it means z is equal to infinity. This is the ROC factor. You have to define this r should be in the some range. That's why I written directly z in the range. To written z in the range, the magnitude of this one will be r only because of this is the angle only. Angle have a node magnitude. If you take the z, then this will be a r. Magnitude of this one will be r only. That's why if you put in the ROC is infinity, this means directly put in the z is equal to infinity. If z is equal to infinity, put in the this whole function will be infinity in the both the case. That's why we have to choose the ROC less than infinity. Any value can choose, but you can't be choose the infinity. That's why I've taken as a less than infinity. Okay. For this
Yes,
one,
sir.
suppose if you put the infinity here, then whole function will be 0, no problem. But if you put the value 0 at z is equal to 0, then what happen? In the both the cases, whole function will be infinity. Then there is also problem. This is not a absolutely summable function because of the sum of the all function will be infinity. That's why this is not a summable function because of pz should be a less than infinity. This is the summation of this one. Pz where pz is equal to z summation of n is equal to minus infinity to infinity xn into r power of minus of n, like that. It should be less than infinity. It is directly written as the z, like that. That's why the we have to put the z but greater than 0. Mod of z should be greater than 0. If you have any doubt or less than 0, then what happen? You have to put in the modulus because of there is a circle. Then positive, negative, no matter. This is the magnitude only. This matter only magnitude because of the circle have a positive and negative value both. That's why there is a magnitude because of we put in z should be some alpha, modulus of alpha, like that. That's why. Then no matter of negative. That's why this will be a 0 to infinity, but less than infinity. You can't not equal to infinity. That's why it's same thing here also. So it will be greater than 0, not equal to 0. That's why the ROC of the whole function will be greater than 0 and less than infinity. In between them, we put in all the value. This function will be summable, absolutely summable. Then this z transform will be perfect. Okay. Let's start the property of z transform. First one same as the Laplace linearity. Linear function. In the linear function, you can add directly two functions xn. If the g transform of this one will be x1z, another is x2. Z transform of this one will be x2z. Then is there any function x3 which is the combination of x3n, combination of both x1n plus b x2n, then z transform of this function will be a1 x1z. You can uh, find the z transform for individual x1 x2, then after you can add simply. There is no matter, both answer will be same. For example, taken as alpha power mind of n. Then what happen this one? This will be alpha power n un plus alpha power of minus of n u of minus of n minus of 1. Then we have to we can find this one and this one as a different function. After that we can add the both. We take this one x1 x2n, then after to find the x1z, then x2z, then we can simply add. Next is the shifting property. Time shifting. Delay or advance. If there is action, I have some z transform by xz. If we give some delay, if n naught is a constant something, or you can advance the signal action n naught. Then you have to check this one minus of n naught z same function value is z of worse something xz. In this case z of need to power something, this will be same value. You have to powering the at the z and simply find the z transform only. Like in for the example, in the previous case you saw this one, it's like have the z transform will be 1, del of n minus 1 z transform will be z inverse, z of n plus 1 z transform will be z power 1, like that. Okay, next one, limit. This is the previous class question. Scaling in z domain. If there is any function have a z transform of this one action function, if you multiply by the same z form like z to power n something, z not have some constant, z not have some constant, not a z only. You can put the any constant value. This is not a Z transform by Z. Then you have to same thing divide by the Z transform same value. If I Okay, jet transform should be in the form of R naught e to power of j omega naught. Suppose I written something for the example, then you can understand better. Xn is equal to un. Then what is the jet transform of this one? Xz is equal to n is equal to 0 to infinity z power of minus n. Because of un minus infinity to infinity un z power minus n. That's why un should be 0 to infinity. Will be in that one. This function will be 1 minus of z inverse and z divided by f. Z minus 1 is the z transform of un. All of you know about that. Suppose there any function yn have multiplication of half e power z pi by 4 and un to power n un. Z not because of this was some r not, so constant value of r and omega d. Then what is the z transform of this one? Yz is equal to z divided by z1, so 1 divided by 1 minus z inverse, then z divided by f half e to power j pi by 4 to power of minus of 1 because of z or minus of 1 z inverse, and at place of z you have put the z by z naught, and this value will be 1 minus, if this is the inverse then whole signal will be upper down e power j pi by 4 into z of inverse, or you can write this one will be z minus 1 by 2 e power j pi by 4. The simple way you can write this one as the alpha power n un also. In this case you have to z minus alpha. Same function I think. You can see here. Okay. Next one is time reversal. If u1 will be a u of minus fn, then what happens in the z transform? Time reversal property. Xn z transform of xz. Then what happen if this will be minus fn? Time reversal. In this case simply you have to put in as inverse of z. At place of z you have to put the inverse only. For example, if the xn is equal to alpha power n un, then transform function of this z transform of this one will be 1 minus alpha z inverse. Suppose in function un is equal to x of minus of n, it means alpha power of minus of n u of minus of n. You have to put the at a place of z, it will be z inverse only in this case. The 1 divided by 1 minus alpha z inverse to inverse. In place of z we have to put the inverse, and this will be 1 minus alpha z in this case. Okay, convolution property. there is a two function x2 x1 x2. Then if there is any function have a x3 n, this one is the convolution of this both function x1 n convolution of x2 n. Then how can you find the convolution in Z transform? Z transform x3 simple find the Z transform of both and multiply of this only. In time domain convolution will be in Z transform will be multiplication. Okay. For example, if xn is equal to convolution of alpha power n un convolution with z del n minus half alpha del n minus half 1. And how can you find the convolution of this function? In time domain, you have to multiply all of things like that. Un is equal to 0 to infinity. But in frequency domain, we have to put simply xz, find the z transform of this one, 1 divided by f, 1 minus alpha z inverse. Then find the z transform of this one, del n z transform is 1 minus alpha z n minus 1 transform alpha minus 1. This will be cancelled out. 1 is the answer. And the inverse z transform this one will be delta n, same thing. Delta n have 1 z transform. Okay. Time accumulation property. What happens if you add the signal in time domain? And how can you find the in frequency domain that signal? This is the new property, sixth one. Xz. Then has if you add this function for minus infinity to infinity xn, then what is the z transform of this function? In this case, simply we have to find the z transform of xn and divide by f 1 minus of z inverse only. This is the final value, initial value. You can add this one 1 minus 1 minus z inverse, the summation of the any function from 0 to 1, 0 to infinity like that, 1 to infinity. How can you write it directly this one? Simply let's check from the example. If there is xn and un, for this one you can write as this one, k is equal to minus infinity to infinity xk and u of n of minus k, and this function n u of minus k because of the unit step function, then you can write as k is equal to 0 to infinity xk. This is the approximately this one. This is not infinity, it's 0 to minus infinity to 1 n. Sorry for this one. Something like that. That's why the function, the z transfer of this one, we can write it as hz into u1 have 1 minus z inverse. That's why same thing is written as this one. Because of this one, you can replace by un. Not a k, sorry, 0 to k, because of there is a k. If there is a not k, only un is there, then you have to take the function from k is equal to 0 to infinity. But there is a u n minus k something. And k something, it means the our whole function on only the on the k till the k only, not infinity. If the k is not there, only un function is there, then the summation will be a k n is equal to 0 to infinity because of un. But there is a un n minus k, that's why this k is equal to 0 to k. Something like that, equal to 0 to n. You can replace by un function this one. In seventh problem, frequency differentiation. When frequency domain, I have to differentiate xn have some z transform of xz, and if you multiplication of n in this case like tut in Laplace transform, this will be a minus of z t d by dz xz. If you mean multiplication of this one, you have to differentiate this in z transform domain. Okay. For example, for this property xn, suppose there is alpha power n un, then what happen? Xz of this one, we all about know this 1 minus alpha z inverse is equal to z divided by f z minus alpha. If some other function is yn, is multiplication of n xn, then you can write this one is n into alpha power n of un, same minus of z d by z xz, minus of z d by z 1 divided by f 1 minus alpha z inverse. We will differentiate this one. Minus of z, to differentiate this one, denominator into 1 minus alpha z inverse, denominator into differentiation of numerator, this is one constant value, minus of numerator and differentiation of the numerator, and divided by of whole square of numerator. This is the formula for differentiation of numerator and denominator. In this case, this is differentiation 0, and this will be value 0, minus of 1 is 1, and differentiation of 1 is equal to also 0. This will be minus minus will be a minus of this one of 1 into z of -1 +1, oh sorry, minus of -1, divide by the of 1 minus alpha z inverse of whole square. Okay, this is minus z also here for this one, and this will be positive one, then minus of z minus of 2 divided by of 1 minus alpha z inverse का whole square. So there's alpha is there, then alpha we have to take a common, and this will be a minus of alpha z inverse divided by of 1 minus alpha z inverse square. If we take z inverse common here, then you can write this will z inverse, it will, at outside there is z inverse alpha z inverse. If you take z inverse common from this one, then outside is z power minus up to, because of this will the square, this will be z of minus of alpha square, this will be positive upper side, and this will be minus of alpha z divided by of z minus alpha square. The final answer of this final z transform form by using the frequency differentiation property. If there is any multiplication of n terms in our signal. Okay. The next property for this one is time expansion. If there is any time division in time domain, if there is any division in time domain, then same thing in frequency domain is time expansion, like that. Because we know about t is equal to 1 by f, if anything in division of something here, or anything is a divide of something here, then frequencies will be increasing, because of if time is decreased, overall time is will decrease, then frequency will be increasing. Same thing formula here, if a time is division of something in time domain, then in frequency domain time of frequency of expansion of that function. I have to expand this one. Same value, which one is divided is in time domain. For example, suppose xn is equal to 1 by 4 power n un. Then what is the z transform of this one? Same thing, alpha power n un. Then 1 divided by f, 1 minus 1 by 4 alpha z inverse. Okay. Suppose if yn is equal to x n by 4, then what happens in here? 1 by 4, 2 power of n by 4 u of n by 4. This will be same thing, we have to power of 4 in z. 1 minus 1 by 4. Okay, fine. This one is a z power 4 power inverse. And overall this one will be 1 divided by 1 minus 1 by 4 z to power minus 4. Okay. This is the whole properties of Z transfer. The next one is a causal system and stability in Z domain. How to find the causality and stability. If A is same thing, if any function have a right side function, this one like that, you can retain as this one is like Hn is equal to 0 at when n less than 0. N is equal to less than 0, whole function is will 0. If but it means if n is equal to greater than or equal to 0, the whole function is Hn. And this type of function will be causal function, causal signal. Same thing, the left side of signal is there. This signal can be written as Hn is equal to 0 when n greater than or equal to 0. In this case, this signal is written as anti-causal signal because of it will be left side of signal. If any signal is hold including the all thing, it means Hn not equal to 0 at n mod of n greater than or equal to 0, all signal are there. Then this type of signal is known as non-causal system. And stability, how can find the stability? Okay, just have taken some example to find the causal and stable system. This will be some taken as 1 by 4 power n u1. Second example of minus of 1 by 2 n u of minus of n minus of 1. Third one is 1 by 3 to power of mod of n. Mod of n will be written as 1 by 3 power n un plus 1 by 3 minus of n u of minus of f minus of 1. For this one, you know, this is the right side signal, then ROC should be greater than 1 by 4. In this case, signal, the left side signal, ROC should be less than of 1 by 2. This is the right side signal, ROC should be greater than of 1 by 3. This is the left side signal, ROC should be greater than less than 1 by 3 to power of minus 1. That's why 1 less than 3. In this case, circle. Is the only unit circle. 1 unit radius circle, 1 is there. Then 1 by 4, where is 1 by 4? Less than 1, it means this one. In this way, less by 2, less than. In this case, 1 by 3, 1 by 3 is less than 1. Another is 3, 3 will be greater than 1. Yeah, this one will be 1 by 4. This one will be 1 by 2. Radius of the circle. This is 1 by 3. This will be 3. In this case, the ROC should be less than or greater than 1 by 4. It means this was like that. This is the ROC in this case. In this case, ROC is less than 1 by 2. It means inside the circle. In this case, ROC will be less than greater than 1 by 3 and less than 3. Then this ROC will be circular region, ring, you can say. This is the ROC, greater than 1 by 3 and less than 3. Oh, sorry. This step signal is stable and causal system. Causal, why causal? This is the right sided signal. And stable signal if the one unit is ROC is including the uh, unit circle radius. If the including the ROC, then the system will be stable system. In this case, less than, then this will be anti-causal but unstable. This is not including the unit radius. Here is the unit radius, this one. The ROC is not including this one. That's why this is the unstable signal. Here, ROC is including the unit circle. That's why the system will be stable but non-causal because of both is there. Non-causal and stable signal. If you want to compare the S plane and G plane, then what is the similarity of this one? Two plane. J omega axis, this will be a unit circle in G plane. This one is the J omega axis. Right half H plane is the outside the unit circle. This is the outside, this one is the, it means right half H plane. Left half H plane, it will be inside the unit circle in G plane. This is the inside the H plane. Inside the unit circle, it means this is the left half H plane. If poles is here somewhere, then ROC is outer sided, then the system will be stable. Like this in case. Okay. Stable signal means simple stability. You can any function if summation of this will be minus infinity to infinity have less than infinity. System, this is the system Hn. The summation of this means this will be absolutely summable function, it will be stable. How to find just some point to find the causal and stability. For the causality, ROC is outside the unit circle. And also order of numerator should be less than the denominator or equal to the denominator. Less than or equal to denominator. If there is a pz by qz, order of pz, if suppose m, this will be n, then m should be less than or equal to n. If greater than this one, so all of things is different. Second thing, for the anti-causal system, ROC is inside the unit circle, and same thing, order of numerator should be greater than the order of denominator. In this case, third one, for non-causal system, ROC is in the form of angular ring. Form of angular ring, it means this one, non-causal system. Greater than something to something, including the unit step, units singular circle. For the stability, ROC must include the unit circle. Okay. For the causality and the stability, both, all the pole must be inside the unit circle. All the pole must be inside the unit circle. Like in Laplace transform, all the poles should be left side of the H plane. Okay. Next one is the initial value theorem and final value theorem for the Z transform. If suppose there is xn have some transfer function of xz, you want to find the initial value, then initial in the jet in time domain initial value is n is equal tends to 0, and frequency domain just tend to infinity. Simply you have to put the infinity. I have not done anything. I have not to done anything in this case. Simply put the infinity initial value. But it will be applicable the same thing for the causal system. Applicable for causal system. Okay. Same thing in the Laplace transform. If initial final value theorem, causal system only applicable, because there is not initial value in uh, anti-causal system or non-causal system. There is a minus infinity something in anti-causal system. Initial value, final value is 0 or something. That's why for the final value in time domain tends, tends to infinity. This will be a 1 minus of z inverse xz, and z tend to 0. Sorry, not 0. Z tends to 1. You have to find the final value here. Is not tends to 0, because of here you have to multiply up 1 minus z inverse, something like u1 inverse of u1, 1 minus 1 minus z inverse, and something apply here and put in the z is equal to 1. You can find the final value of this function. Suppose there is something, for the example, xz is given 0.5 divided by of 1 minus 2 z inverse. Then what is the initial value of this? Suppose system is given as an anti-causal system. If you put a directly z is equal to infinity here, then we will find something. Not infinity, we will find the value of something. But the system is given as anti-causal system, then how can you justify this one? In this case, we have to find the u1, xn. We know about this one, 0.5 common, and we have this one, 1 minus of 2 alpha z inverse, you can say, but system is anti-causal system. Then the causal system 0.5 minus alpha power n u of minus of n minus of 1. The alpha is here is 2, 2 to power n u of minus of n minus of 1. Because of anti-causal system. In causal system, simply this will be a 2 to power n u1, multiplication of 0.5 only. This is for the causal system, but the question is given as anti-causal system. That's why in this case you have to put at the left sided you have to put this one u of minus of n minus of n. This whole system will be like that, behaving like that, u1 minus of 1 only. then initial value is you don't be find the initial value, or can't be find the, sorry, can't be find the initial value because of this is the minus infinity to 1 in this case. That's why in anti-causal system you can't find the initial value. Initial value can be find only in the causal system, which will start from 0 to something infinity. This is the causal system. Initial value is from start from 0 at point 0. We can if n is equal to 0 put in, and we can find the initial value of the system, causal system. But in the anti-causal system, we can't find put in the n is equal to 0 because of the system is not present at the n is equal to 0. That's all. Suppose you have a question. If a function have xn is equal to 1 at n is equal to odd, sorry, n is even, and 0 when n is odd. If the function is this one as a causal system, then find the final value of this function. Of the system. Find the final value of the system. How can you find the final value? It may be 0 or 1 only. And what is the final value? If it's if this type of function is given, x is equal to 1 and n is equal to even, it means 1 0 1 0 1 0 is a function. 0 is odd or even. 0 is countable in the even function. That's why xn can be written as like that: 1 0 1 0 1 0 1 0 dot. But final value is not mentioned here. That's why can't we say the final value. What is this one? You will start it from causal system. That's why the value is started from 0. This function in graph you can plot like that. At 0 it will be 1, at 1 0 this will be 1 2 3 4 5 6 7 8 dot to have some value 1 3 0 5 0 6 8 like that. Can you find this type of signal? If you have an expression, then you can find easily the z transform. After that we can apply the final value theorem, and we will get the final value of this function. But here we can't be directly predict the final value. It will be 0 or 1. Then how can you find? First you have to find the expression of this signal. U1. Suppose U1. What is U1? 1 1 1 1 dot infinity. Arrow is here. And now from 0 to 1 like that. 0 1 2 3 4 like that. You have to put the 0 between them. Then you have to expand this function. Time expansion, it means n divided by of 2. Then you have to put a 0, n minus 1 0. There is a 2. Then you have to put 2 minus 1 0 in between, in middle of this one. arrow is here 1, then put 2 minus 1 0 is 1 0 1 0 1 0 1, like that. It means this system will be written as like u of n by 2. So what is the Z transform of u1? All of you know about this one. 1 minus of Z inverse. Then what the value of u n by 2? Simply in place of Z, you have to put the square. 1 divided by of 1 minus Z of square inverse by the property 1 minus 2, so Z to power minus 2. Z to power minus of 2. Then apply the final value theorem. Final value theorem. Final value theorem says the xn, if n is tends to infinity in next domain, 1 minus of z inverse xz divided by n tends to n is equal to 1, tends to 1. Okay. Then in this function apply 1 minus of z inverse into 1 divided by of 1 minus of z power minus 2. Suppose if you put the z n is equal to sorry, this is not n, this is z. Whole function is z, that's why this will be z. You put a z is equal to 1, then what happen? This will be 0, this will be 0, so 0. Oh yeah, why this is a type mistake? This is also 0, this is also 0. Both are 0 by 0, not defined. Then what happened? You have to expand this one. Denominator 1 minus of z inverse. You can written as this one 1 square minus of z minus 2 z inverse square, like a square minus of b square, which will be a plus b and a minus b. Something right here. A plus b, it means 1 plus z inverse into 1 minus of z inverse. Then 1 minus of z inverse will be cancelled out. 1 divided by f 1 plus of z inverse, and z tends to 1. Put the value of 1 here, and final value is 1 by f 2 is the final value of this function. Not a 0, not a 1. Okay. Okay, everyone, let's stop there. And inverse Z transform and Fourier series is started from the next session. Okay, thanks to everyone. Okay, everyone. Thank you.